where we get into trouble is when a triangle shares a certain part of a triangle. So, like, we have this problem on our homework. This was number 15 from 7.3, if you guys remember right. Okay, you had AB, and then you had D drawn down. Okay, I know I drew that straight, but it's not necessarily straight. And then I had an angle here and an angle there that were similar, and this was point C. Okay, it said find length of AB, and it gave you, I think it gave you that this was 12, this was 4. Okay, gave that was 12 and this is 4. And if you lined it up wrong, you're going to get the wrong answer. Okay, because I know AB, right? If I'm sitting here thinking that just triangle ABC is similar to triangle ABD, without lining it up right, I'm going to say, hey, AB is similar to AB, right? So I can put that over it. Well, is AD similar to AC? Is 4 similar to 16? No, 1 doesn't equal 1/4. Okay, so that's where you get in trouble when you are doing this, because I didn't name it properly. So let's look at the way I named it. I said that in the big triangle A, triangle B, and triangle C, I guess I should say, are these similar, right? So I have a big triangle ABC, which has an angle at A and an angle at C. That angle at C is congruent to part of angle B and angle B in the little triangle. So ABD is similar to BCD, okay, or BCA, okay, and then it is also, angle A is reflexive. So I do have angle-angle similarity. I have angle-angle similarity, right? So then what we want to do is, of course, line up my statement correctly. So if triangle A and triangle A, are they corresponding to each other? Yeah, they're both similar to each other by the reflexive property, right? Now, if I look at my drawing, angle C corresponds to angle B. So in my big one, I need to put C next, and I need to put B there, okay, in my little one. Then we finish up with what my third angle must be. So angle D must be equal to angle B. So angle D must be equal to the big entire angle B. So I can see that triangle ACB is similar to triangle ABD. Then when I line up my sides, AC, okay, my first two over those two, over AB should equal, let's see, what is it? My last two, which is CB, right there, those are my last two, over BD, which should equal my first and my last, which is AB, over AD. Now, we got a couple questions today, like why would I want to write out 3? Because I don't necessarily know what I'm doing. I am trying to find AB, so I'm going to leave those. So everywhere there's an AB, I'm leaving it. That's what I'm trying to find, right? AB. Do I know the length of AD? Well, AD was 4. Do I know the length of CB? No. Okay, so we didn't know anything about CB, right? So I'm going to leave that one blank, or I could write CB, all right? And did I know BD? Well, it didn't give me any length about BD either, so I'm going to leave that one blank. Now, did I know anything about AC? Well, AC was this entire side, so that was 16, 4 plus 12. Now, I can just ignore this CBBD because AC over AB is still equal to AB over AD. So I can write a 16 over AB equals AB over 4, okay? 16 times 4 equals 64. AB squared. AB equals 8, okay? So that's why it's important to get this statement lined up right. Then we went on to 7.4, okay? And there's a couple theorems in there, all right? We're going to start out with the triangle proportionality theorem. And all right, so you have a triangle. Okay, and I'm going to choose a line that you guys aren't going to look at because we've seen it drawn a lot this way. So I'm going to draw it this way. Okay, and I'm going to say that this line is parallel to that one. All right, that line is parallel to that one. Okay, if I name this A, B, C, and I'm going to give this, I'm just going to call this R, and S, just to mess up the variables a little bit, okay? The triangle proportionality theorem says that AR over RB equals AS over SC, okay? So let's plug in some numbers and just do an example problem. Oh, SC, sorry. Let's do an example problem. Let's go 4 and trying to find something that's not completely easy. Let's go 12 and let's go 7 and 21, right? First thing I want to look at, hey, are these triangles similar? Well, yeah, because they are, because I have a reflexive angle at A, and then I have parallel lines, so I have corresponding angles and cut by a transversal or of parallel lines, okay? So I have AB over RB equals AS over SC, okay? Let's plug in those values and just see if this works. So AB, oh, I'm sorry, this is AR. AR, gosh, I'm making mistakes on here. AR, so 7 over 21 should equal 4 over 12, which of course those come down to 1/3 because I made those numbers, all right? So now if it gives you a variable that says find x and you have parallel lines, triangle proportionality theorem. Wherever I had 4 before, let's go 7 over 21 equals x over 12. Do the exact same thing and solve for it, okay, by cross multiplying. Okay, so we just want to make sure that we get our proportions set up right. All right, now where we're going to go wrong is, can we use the triangle proportionality theorem if I give you these numbers? So I was multiplying by 3, right? So let's just go 3 and let's go 9, right? 3 and 9. So it kind of follows that pattern right there, those. Well, if I set the length of 3, which is my base of my little triangle, right, over my base of my big, 3 over 9 equals 1/3, right? Well, so then the same should be true if I set 7 over 28, which is the entire length right there, okay? Which isn't true, okay? So you have to make sure that you are using the full length of the triangle if you're trying to find the length of parallel lines, and you're setting up a ratio such as this. So this is an x, and we called it 9, right? Well, let's change that. We'll keep that 3, and we'll keep this that. We'll call that x, since the numbers are going to get kind of bad if I do it that way. So now if I set up my proportion, 7, my length of the little triangle, over 28, my length of the big triangle, equals my length of the little triangle, 3, okay, over my x, I get 7x equals 28 times 3. I know that 28 is really 4 times 7, so I'm going to get x equals 3 times 4, or x equals 12, okay? Need a new piece of paper. All right, then we had the inverse of that, or the converse, okay? And now I'll draw my line like this, since this is how we normally see it. Oh, I don't want to put in that parallel mark. Ignore that parallel mark, okay? Let's say I gave you x over y equals w over v. If x over y equals w over v, then these lines are parallel. And that was the converse of the triangle proportionality theorem, okay? So if my sides are cut proportionally, then that's parallel. That's a parallel line, all right? Going along with this one was our two transversal cut parallel lines corollary. I'm going to put my phone down real quick to draw this. Okay. So I created 3 parallel lines. Okay. And then here's my 2 transversals. This splits up in a way that is proportional, okay? I keep using AB for lengths. So let's just talk about lengths. Let's say that this is 6, okay? And this is 18, right? This is 7, and we're trying to find x, all right? And we've always called this A, B, C, and then D, E, F. And remember, the corollary said that if I have two transversals cutting multiple parallel lines, there's the way that they're being cut is proportional. So AB over BC should equal DE over DF. DF. Or 6 over 18 equals 7 over X. X equals 7 times 18. 6X equals 7 times 18. I know that 6 goes into 18 as a 3, so then I get X equals 21. All right. That's how you use the corollary one. Okay. Then we have the triangle angle bisector theorem, which if you had a triangle cut by an angle bisector, it's either going to tell you it's an angle bisector, it's going to give you those marks. All right. Then it gave you some math. All right. And how we make this harder is we go X plus 2 equals, let's see, 7 and 4. I just made up these numbers, so I don't know what X is going to come out to. What the triangle angle bisector theorem says is that 4 over X, or that the way that this angle was, or this angle bisector split this, is proportional to the length of these sides. All right. So X over 4, my segment over the side. You could also do the side over its touching segment. Okay, should equal this segment over its side. X plus 2 over 7, which I'm going to get 7x equals 4 times x plus 2. And we'll see how well I made this problem. I get 8x plus. So I made this problem really bad because I got negative numbers. 8x plus 8 equals 7x. Which that's bad values for me. Okay, so let's completely ignore that one. Let's do one that works. All right. And let's do it a different way. And let's just find a 1 value. Like I said, I made up the values for the last problem, so I didn't really know how they were going to go. But that's how you do it, is you set it up like that, okay? So let's go 4 and 6. All right, so that side's 4, that side's 6. And then let's just go 2 and x. And let's find out what x is, okay? Now, we set this one up as segment over leg. I'm going to set this one up as segment over segment. So I'm going to set it up as 2 over x equals the segment I had, which was, or did first, which is 4, that leg, over the other leg, which is 6, okay? And in this one, I get 12x when I cross multiply, or I get 12 equals 4x. It's 4x, x equals 3, okay? So that's how you do that triangle angle bisector theorem, okay? Then we went on to 7.5. In 7.5, we were using triangles to find real life. So if there's a shadow created by the sun, right? We knew that the angle that the sun makes, okay? And then how a person's standing, we had angle. And then you were missing a height, but you knew the shadow. And you knew this height and that shadow, okay? We also went to using a scale. So we had a map or something, okay? So let's just say this is a blueprint of Mr. Cole's classroom, right? Now, is Mr. Cole's classroom that big? No. Mr. Cole's classroom is actually really big, okay? But let's say that we had a ratio scale of 1 to, for every 1 inch on this was 30 feet in Mr. Cole's classroom, actually. Now, I get let's go 10 feet, so it's not completely ridiculous, okay? And I have that this length right here, and I measure it by a ruler, is 2 inches, right? 2 inches. I want to know how big is Mr. Cole's classroom actually, right? So I'm going to go 1 inch over 10 feet equals 2 inches over x, where x is my actual feet of Mr. Cole's real classroom, real life. I don't have a picture drawn here because we're talking from going to from a scale back to real life, okay? I have my scalar ratio, all right? And then when I multiply that out, I'm going to get 20 feet equals x.